Alright, this is problem number 6 on the blue worksheet. So this says that we have a ne'er-do-well, which is a rapscallion or a rascal, that wants to toss a bag of precious jewels over a 3.05 meter high fence. She must stand 0.64 meters from the base of the fence and can release a bag at 1 meter above the ground. How fast should she toss the bag and at what angle for it to make it over to the other side? So we're looking essentially for our V initial and our angle. So plugging in the information that we have, our delta Y cliff is 1 meter. And our delta Y peak to ground is 3.05 because we're just trying to let it clear. So we have to get just over. So realistically, like 3.051 would be acceptable, but we can just work with 3.05 and we'll still get pretty much the same answer. So what we know is that our delta Y peak to ground is always the sum of our delta Y cliff and our delta Y cliff to peak. So we know the peak to ground and the cliff at this point. So we could figure out how high above the release point the projectile will actually have to go. So that's going to mean that we'll take 3.05 and subtract 1, and that's going to be 2.05 meters. So ultimately our projectile only has to travel upward 2.05 meters from its starting point to get over the fence. So knowing that delta Y cliff is going to let us find a couple other things based on the problem. So we know that if we're trying to figure out the V initial and the Y, we can go right to that without needing to find time. So we could do V final Y squared is equal to V initial Y squared plus 2G delta Y. So again, we don't need time. We could if we wanted to, but we don't actually need it. The V final in this situation is going to end up being 0, and that's because we're hitting the peak. So 0 squared is equal to V initial Y squared plus 2 times negative 9.81 multiplied by our delta Y that we just found of 2.05, because that 2.05 distance is covering from our starting point to our peak height. So moving everything around, rearranging, solving, doing the algebra, we're going to get a value for our V initial Y, and that's going to be 6.342 meters per second. And that value is how fast we are actually leaving in the vertical direction. So the projectile will move up initially with that velocity and then effectively slow down to 0. So we're trying to figure out how much time it's going to take to actually get to the fence. And that's going to help us to figure out a couple of other things. So we know that V final Y is equal to V initial Y plus gravity times time. We know V final Y is 0. We know V initial Y we just found, gravity and time. Calculating this is going to tell us that when we reach the height of 3.05 meters above the ground, which is where we are at the fence, we will know that the time has been 0.646 seconds. So after release, 0.646 seconds later, our projectile will be at the fence position vertically. So now we're trying to figure out with what horizontal speed we need to launch it to make sure that it actually gets there. So the distance that we're standing away is 0.64. The time is the 0.646. So doing that division is going to give us an x velocity component of 0.99 meters per second. So essentially, we need to toss that bag horizontally at 0.99 meters per second, and then vertically at the 6 meters per second that we calculated for V initial Y to clear the fence. So our overall V initial always follows this equation, Vx squared plus V initial Y squared. That's because we have a right triangle when we solve. V initial Y is the vertical, V initial X is the horizontal, and then we have our overall V initial as the hypotenuse. So plugging in the information that we know, V initial is 0.99 squared, and that's going to be added to our 0.6342 squared. Take the square root of that relationship, and that's going to get us our overall initial velocity of the toss. So when the question says, how fast should she toss it, we are looking for the overall initial velocity, not the x or the y individually. Doing that math, we get that the velocity is 6.42 meters per second. So it's a little faster than it was in the vertical, which makes sense because that x component isn't very large, but it is making some contribution. So then to find the angle, we are going to use the sides that we know. So x and y. We'll do tangent because they are opposite and adjacent. So VOX divided by VOY is equal to tan theta. Do that algebra. So the tangent of theta is going to equal 6.406. Take the inverse tangent of that number, and we are going to get that the angle is going to become a relatively large value. You can tell just by the numbers. It's going to be 81.13. So the y component is a lot greater than the x component, so that means that the angle has to be pretty close to 90 degrees.